Part one of the ArchiCAD Tools series. We are looking at what is basically a work in progress template here, but we'll kind of brush to the side of that. I'm going to start off by talking about the wall tool. Here on the ArchiCAD work environment I'm working from, my info box here gives me the bridged shorthand version of the wall tool. Most importantly, with all tools on the info box is this geometry method. This is what allows me to draw out 4 walls at once, draw out segments of walls as a running chain of walls. Important to note that these walls are independent of each other. Even if you draw them out together, they're independently selectable. Under the Edit and Grouping menu, there's an auto group function which allows you to draw walls out and they group together after they're placed. But that grouping can be suspended to select those individually. There are also additional wall types, rotated, skewed, distorted, whatever, radial walls, etc. The radial walls, you can actually draw those as a polygon. Here in the pet palette gives you options for giving the radius and circumference of that wall. So that part is pretty simple to do even without having to select a different wall type. So the most common wall type when you're drawing a wall is this geometry method, the straight single chained wall. If you want to place segments, you just hold Shift, type R, that gives the radial distance, and you type in the length of that wall segment. When you're done placing segments, you just click on the end of the wall. If you find yourself placing multiple segments and you get a segment that's off, if you hit delete, it'll deselect that segment and you can then proceed to place it again. If you hit escape, you start over from scratch. So that's a few just kind of quick bits of information on placing walls. The actual wall settings now, if we look at the settings dialog, Command T is the shortcut to get to wall settings, and here I see the full list of settings. The only settings I don't get in here are those geometry method options. So here we can look at all of the various settings that define the geometry, the surfaces, the pens, the appearance, and positioning of this wall type. The most important setting within the wall tool is this reference line setting. The reason that this is important is because this is the vector that that wall is based on. So if we zoom in on a wall here, you can see that my on-screen view options are highlighting that reference line. That's under View, on-screen view options, and wall and beam reference lines. So that can be a little bit distracting because that's not the pen weight or pen color we want to see. So we can hide that piece. But then you can see it highlight blue here. By this work environment, I'm defining that wall type as blue, or the reference line, sorry, as blue for that wall type. And you can see the various buildup of this wall. So I have a layer of siding, a layer of sheathing, my reference line, the core, and the interior sheathing. Now, if I redefine where that reference line is, say core of center, notice that the line itself does not reposition. That line is the constant, and this is why that's the important setting. If I were to switch this over to, say, a 2x4 wall, for example, the wall shrinks from that point inward. So it's important that you understand the design intent of the project when you're placing these walls. If it's a steel building, it probably makes sense to put that on the center of the wall. If it's a light wood frame building, it might make sense for that reference line to be on the face of stud. But placing that wall deliberately so that as the wall may grow or shrink, or siding and finishes may grow or shrink in the future, that constant is in that fixed position. For most projects, the inside or outside face of finish is going to be one of the worst positions to put that. Because if you go from 5/8 to 1/2 inch gyp, for example, or from 1/2 inch gyp to 1 inch lath and plaster, that's the constant. So you're actually moving the stud or the framing in or out. Additionally, it's important to relate the wall to the building height in most cases. So even if the wall is, say, maybe it's an interior wall, it needs to stop at the bottom of the flooring, it could be -12 inches to the next floor. But linking the height of that wall to the story settings means that globally within the project, if we look at this wall in 3D, if I were to go to my story settings and change the floor to floor heights, first floor to second floor, 12 feet maybe, that wall stretches with it. So I'm not going through and meticulously adjusting wall settings just because the story settings went from 10 feet to 12 feet on my floor-to-floor height. So those are the two primary most important parts of the wall settings. Now if I had maybe a partial height wall or something that wasn't linked to those story settings, maybe it's like a low guardrail type situation or even a curb wall, I might want to first show that as outlines only. What that's going to do is show just the outline of the wall. That also unlocks a few other wall settings here that we don't have by default. So the uncut pen was hidden when it was set to projected with overhead or cut only. And now I can say that this wall maybe isn't linked to my story settings and it's only a 3.5-foot wall if it's a guardrail type situation. So that is one situation where you may need to unlink or have an independently set wall height. The wall's position to project 0, to average grade, max building height, sea level, or current story. This is a very common, like you put it to current story if it's sitting on that floor level. So those are some various settings. We also have the wall extrusion or geometry. Again, that wall is an extrusion along that vector. So setting the wall shape, essentially, this is that extrusion shape. We have basic building materials. These are what the wall is made of. Now, it may seem like it's a good idea to set this to like an 8-inch thick concrete wall. But you might have, say, 15, 20, 100, 150 different 8-inch concrete walls. And if later on the engineer comes back and says, well, all of these walls need to be 10 or 12 inches or whatever else, you have to go through and pick out each of those 150 walls to find them and set them to whatever that new dimension is. If you want global settings or global control for the geometry of those walls, you set the attribute type. That's what this piece is right here, the attribute to a composite. And even if that composite is only a single layer or a single level, like this 8-inch concrete wall, that means that I can go into my attributes and my composites and say that my 8-inch concrete wall needs to be 10 inches, for example. Bear with me while I reserve that. But it gives you a global control to say that this needs to be not 10 feet, 10 inches. And then that wall adjusts through the whole project universally. So it gives you better control over what those geometries are without having to go through and make sure that you caught all of the settings. So display options for the wall, you only really have home story and all relevant stories. All relevant stories really ties to your view settings for floor plan cut plane settings. So if the cut plane is not cutting through that wall, regardless of how tall the wall is, it could be extending 3 feet into the next story above. But if the floor plan cut plane is at 4 feet for that story, that wall doesn't become relevant. Unfortunately, walls are pretty limited in that regard to showing on multiple stories. For that reason, we oftentimes will cut walls, split walls into multiple segments vertically and horizontally so that they show, for example, parapet walls might be a separate wall from the wall that they're sitting on below. And again, the projection settings, projected with overhead basically means that if it's, if I raise this up, say 8 feet or something, now that's an overhead wall in 3D. So it shows with that projected or that overhead line type and pen setting here. And then we have our surface overrides. These model settings are uniform for almost all tools. These are some settings that I'm probably going to skip over in future tool videos because we do use these relatively universally for almost all elements in ArchiCAD. Doors, windows, and objects may be the exception. But this is what allows us to basically say that we have concrete as one building material, but one concrete may be board form and another concrete may be slab, for example. You can link these walls together or these surfaces together so that they're universal, or it can be inside, outside, and end surface separately. So I could set the end surface to a different surface material if I needed to. The last setting, and maybe one of the more confusing ones to kind of wrap your head around, is the junction order. So if I have two walls coming together here like this, and then maybe a third wall, find that intersection here. Oh, there it is, because I'm on the inside edge of that. Right here, you get some kind of weird, funky stuff like this. The cause for this is largely because the wall reference lines aren't coming together or aren't coming together correctly. Oftentimes, you'll need to adjust where that reference line is, even though maybe it makes sense that it's on one side or the other. in order to get these to intersect correctly. So once you get them intersected correctly, that is all the reference lines coming together, if they still are not joining up, and bear with me here while I figure that out. Okay. So we get those joining up. It's, this might need to shift over whatever half of that distance is to get that to offset. Maybe it needs to be the core outside in order to shift properly. But if they're still not cleaning up quite right, like this or this little node right there, what you can do is sometimes bump these up or down a little bit so that these intersect before this one comes in, and that'll clean up some of those. Oftentimes it's a bit of a double-edged sword where it'll clean up some and not others. There are ways to work around that, and we may get into that in some more advanced modeling techniques. The last setting to be aware of, and really it is the last settings, and that is down here at the bottom. We have the layer. It is important to put things on the correct layer. We have our A wall layers, our A roof layers. They're all pretty self-explanatory for the most part, interior and exterior wall layers. And then we have our classification settings. Classification is really what defines this as a wall in the BIM world. So if we're sending IFC files or coordinating with consultants, we do want to make sure that that IFC classification is set so that we are sending this out as a wall to a Revit user. Revit doesn't understand that this was made with the wall tool, it just knows that this geometry exists. In order for that to be a wall family in Revit or a wall element in any other BIM authoring tool, it has to be defined as a wall in the classification. Classifications can get really detailed. There are subparts to stairs, subparts to ramps and railings and curtain walls and coverings. But really, if you're just saying that this is part of a stair, call it a stair. Part of a railing, call it a railing. For the most part, using these elements and construction elements is going to give you the best results for coordinating in IFC. That's all we have for the wall tool for now. Thank you for watching.